Quadratics. Now, when we start off with quadratics, we should be knowing equations. Y is equal to ax plus bx plus c. Y is equal to a x minus h whole square plus k. Y is equal to x square minus sum of roots with x plus product of roots. Now, normally, sum of root and product of root of quadratics is tested in A2 math. But these are the three forms of quadratic equations that you can be tested on in the entire syllabus of A-level mathematics. Now, considering, let's just start off with the example of sum of root and product of root, a slight bit of quicker example. If I say that SOR is sum of roots and POR is product of roots. If a given equation is y is equal to x square plus 5x plus 6, I can easily say that this can be written as y is equal to x square plus 3x plus 2x plus 6. Y can be written as x plus 3 plus 2, x plus 3. So you will have two values, y is equal to x plus 3 and x plus 2. When y is equal to 0, you will always have equation. That means x is equal to 0 and x plus 2 is equal to 0. You will have two values, x is equal to minus 3 and x is equal to minus 2. Now, these are the two roots that you have for the quadratic equation x square plus 5x plus 6. Now, considering that I have these roots, now roots are x is equal to minus 3 and minus 2. If we apply the x square minus sum of root of x plus product of root, sum of root and product of root, which means y is equal to x square. Minus is outside the bracket. We'll have minus 3 plus minus 2x plus product of root will be minus 3 multiplied by minus 2. Y is equal to x square minus minus will be minus 5x plus 6. So the final answer will be y is equal to x square plus 5x plus 6. So if you note that sum of root, with the help of sum of root and product of root, from the roots, you directly landed to the equation of the given equation, which was there in the initial start. That means some roots can be used to form the quadratic equation as well. Then we should be focusing on completing the square form. If y is equal to x square minus 8x plus 12 is there, y is equal to a x minus h whole square plus k. That means this is another form to represent quadratic equation, which is known as you're completing the square form. Now, if we need to change this to completing the square, So what we need to do, we need to use comparing method, which is comparing coefficients. Comparing coefficients, which is x square minus 8x plus 12 can be compared to a x minus h whole square plus k. If we open your a x minus h whole square plus k, this will be open as x square minus 2xh plus h square plus k. X square minus 8x plus 12 can be written as ax square minus 2axh plus ah square plus k. Now, this is entirely open form of the completing the square form, which means now what I can do is I have this square here and I have this ax square on the right hand side. So if I just compare x square with ax square, x square cancel, there is always a coefficient. So that means a value is what? 1. If we compare minus 8x with x, so we'll be comparing it with minus 2axh. So minus 8x is compared to minus 2axh. Minus minus is x is cancelled, minus minus is cancelled. 8 is equal to obviously 2, 1, h. So 2 divides on the other side, h becomes what? 4. The other thing that we are left with is ah square plus k. Now, we can't see any x square, we can't see any x. That means this ah square plus k represents the entire constant number. And the constant here is 12. So we'll compare this with 12, ah square plus k. And we know that in a we had 1 and for h we had 4. So we'll put down square. So that means 12 is equal to 16 into 1 is 16 plus k. So k becomes what? 12 minus 16 is equal to k. K becomes minus 4. So if I say that your equation, which was y is equal to a x minus h whole square plus k, this can be written as 1 x minus 4 whole square minus 4 because of the given question of quadratic changed to what? Completing the square form. And this is known as what? Your completing the square form in terms of a x minus h whole square plus k. In question that can be asked by the examiner, your form can already be shown as a x plus b whole square plus c, or it can be even changed with the variable c x plus d whole square plus e. So if the variables are changed, we will be solving as it is, as we solve the above question. We'll be opening up the completing the square form. That means x square minus 2 plus 2xd plus d square. This will be opened and multiplied with c. Similarly, the above equation will be multiplied by a. And then we will be comparing with the given quadratic equation. Let's do another example. Y is equal to 2x square minus 12x plus 8. But now I would like you to change this to a x plus b whole square plus c. The original equation that is given is a x minus h whole square plus k. But in the question, the other equations can also be given. So if we change this to x square minus 12x plus 8. If you want to change this to the given equation, that is a x plus b whole square plus c, we will be opening up the bracket first. 2x square minus 12x plus 8 can be written as a x square plus 2xb plus b square plus c. 2x square minus 12x plus 8. This can be opened up as ax square plus 2axb plus ab square plus c. Knowing the fact that it will be compared, 2x square will be compared to ax square. So a value is 2. Minus 12x is equal to 2axb. X is cancelled. Minus 12 upon 2 is equal to, let's just solve the above value first. Let's say 2 2b. We could have already solved the above value, and then b is what? Minus 3. Similarly, we have 8 and the constant represented by variable is ab square plus c. So a is 2, b is minus 3 square plus c. 8 is equal to 2, 9 plus c. So that means 8 is equal to 18 plus c. Value of c will be minus 18.